Good evening. I'm Darwin Kumarville and my ID number is 17009273.
My name is Jack, student ID 17009456.
Hi, my name is Muhammad Al Imran bin Ahmad.
Hi, my name is Noriza Norsham. My ID number is 17008233.
Hello, I am Tang Zhongwei, student ID 17009981.
As an introduction, our group chosen the oil and gas industry. This is because in terms of the dollar value, the oil and gas industries are considered to be the world's largest chemical industries due to it being a global powerhouse. In Malaysia, we stand to be the second largest oil and gas exporter in the whole of Southeast Asia. This makes the oil and gas industry as one of the country's largest revenue streams. Malaysia has the refining capacity of 880,000 barrels per day. However, with this massive growth, waste disposal becomes a questionable factor due to the massive rise in the industry. As for the problem statement, the world's increasing concerns regarding sustainability has focused interest towards making sure the oil and gas industry in Malaysia is as environmentally friendly as possible and at the same time minimizing the waste production from the industries. As for the objective, this project will research regarding the zero waste management approach for the oil and gas industry in Malaysia and create an effective waste control system along the way.
Thank you. Now I present about the process controller. Petroleum refineries are one of the major sources of air pollution due to emitting hazardous and toxic gas like sulfur dioxide. The emission of sulfur dioxide will affect the respiratory system, affect the lungs, and can irritate the eyes with just short-term exposure. It is also one of the GHGs that harms the environment. High concentration of SO2 also contributes to formation of acid rain and can form other sulfur oxide, which leads to water pollution. To avoid this happening, a treatment method for SO2 gas was introduced, which is called flue gas desulfurization (FGD). FGD is a treatment process for SO2 gas, which the flue gas will be contacted with limestone slurry or lime. Then it will absorb the SO2 gas and becomes a white sludge of calcium salts. This end product can be safely disposed. The schematic diagram here is the reactor system for SO2 reduction. The process controller that is used in the system is mass flow controller. The structure of mass flow controller can be explained based on the figure below. Firstly, gas will enter from inlet and split to flow past sensor or through the bypass. Second, sensor will detect flow rate as a proportional change in temperature and it will be changed by the bridge circuit to become an electric signal. The signal will be sent through the amplification and correction circuit and it will be sent to the comparison control circuit at the same time. At the comparison circuit, the flow rate setting signal will be compared with the actual flow rate and send a different signal to the valve driving circuit. Lastly, the flow rate control valve makes the different approach to zero. The tuning of this controller is PID. PID stands for proportional integral derivative. It is used widely in industry because its combination gives a quicker response, decreased offset, and can remove the offset. The example of mass flow controller with PID tuning is CEB3032 mass flow controller. It has very high speed and super fast analog. Mass flow control is very efficient to use in the reduction process of SO2 gas to achieve the desired output. That's all from me. Thank you.
Next is the challenges for the system controller. In the system, mass flow controller MFC and PID controller was used. The first challenges for mass flow controller are internal control valve in most mass flow controllers only operate with a limited differential pressure. When metering gases into high pressure application like reactors used for FGD and reduction process of sulfur dioxide, difficulty may happen. This because the orifice in the MFC solenoid actuated control valve are precisely selected for the intended differential pressure. These valves have tuning and range issues due to large variation in differential pressure. Other than that, differential and fluctuation in downstream pressure might disrupt the MFC flow rate stability because the PID controller must respond to fluctuating pressure. Moreover, the usage of PID controller may also affect the performance of sulfur dioxide reduction process, since for an integrated process with a long time delay, PID controller show poor control performance. In addition, controlling set point tracking and disturbance rejection of SO2 reduction process in PID controller also difficult. Furthermore, controlling the integrated process is especially to control the flow rate of SO2 gases that will go through the treatment and reduction process, also backbreaking, since the flow will be turbulent and time consuming to calibrate the controller in ways to get accurate tuning.
Let's move to recommendations part. So the first recommendation to improve the control system is adding programmable logic controller. By adding programmable logic controller, programs can be added into the control system, improving its flexibility and reliability. And especially design program added to the control system, it enables the control system to work with a variety of input values. Also, programming allows the system to troubleshoot issues automatically when random situation occurs. The main advantages of programmable logic controller is that it is not expensive and it does not need frequent maintenance. For the second recommendation, fuzzy logic controller can be added to the control system. For fuzzy logic controller, inputs are converted into fuzzy sets, which are something like large positive and medium positive. This process allows complex and imprecise process data to be considered, as they will transform into logics that are easy to be interpreted. Lastly, decision-making intelligence in fuzzy set logic controller can produce output and make decisions automatically based on the rules added by the operators before the process, and is commonly if-then rules. The main advantages of fuzzy logic controller is that it is flexible to deal with uncertainties and non-linearities, while at the same time it does not need complicated mathematical modeling.
In conclusion, oil and gas is a highly important sector of the Malaysian economy. To meet sustainable development goals, zero waste in the industry is being explored. Mass flow controller with PID tuning is a way to reduce the amount of SO2 being released from the industry. To counter the difficulties in using MFC, it is recommended that a programmable logic controller and a fuzzy logic controller are added. It is hoped that these recommendations will make reduction of SO2 easier.